All right, so this section is going to use a little bit more of the probability that you knew before we started this chapter. Okay, so we got a couple different vocab words that we need to talk about. So a compound event combines two or more events using the word and or the word or. Okay. Mutually exclusive events have nothing in common. Okay, so something like this would be a mutually exclusive event because probability of aces, probability of kings. Okay. Overlapping events have at least one common outcome. Okay, this is an overlapping event where you have probability of a heart, probability of a king. Okay, so how you're going to go about identifying the actual probability is if it's a mutually exclusive event, you're going to take the probability of the first one, so that's 4 out of 52, plus the probability of the second one, so 4 out of 52. So we get 8 out of 52. And then you can simplify that if you want to, but you do not have to simplify it. So for overlapping events, we're going to start the same way. So probability of a heart is 13 out of 52, plus probability of a king is 4 out of 52. Now this time though, we have to subtract how many overlapping pieces we have, which is 1 out of 52. Okay. So 13 plus 4 is 17, minus 1 is 16. So 16 out of 52 would be my probability. Okay. All right, so you roll a number cube, so roll a die. Find the probability you roll a 2 or an odd number. So probability roll a 2, 1 out of 6. An odd number would be 1, 3, and 5, so that would be 3 out of 6. Okay, are these overlapping or are they mutually exclusive? Okay, well there's no 2. 2 is not an odd number, so these are mutually exclusive. Okay, so you would get 4 out of 6 as your total probability. Second one, you roll a number cube. Find the probability that you roll an even number, so that's 2, 4, and 6, or a prime number, which is 2, 3, and 5. So probability of an even is 3 out of 6, plus probability of a prime is 3 out of 6. Now, 2 happens to be in both pieces, so we have to subtract 1 out of 6. So 3 plus 3 is 6, minus 1 is 5. So we get 5 out of 6. So that's mutually exclusive versus overlapping. Okay. Next thing we're going to talk about is independent and dependent events. Okay, so two events are independent if the occurrence of one event has no effect on the occurrence of the other. So basically, if I roll a dice and pick a card out of a deck of cards, me rolling the dice doesn't affect picking a card out of the deck of cards. Okay, the way that we're going to talk about it is with marbles. Okay, so a bag of marbles, if I take one marble out but put it back and pick another one out, that first one doesn't affect the second one. The second event is a dependent event where one occurrence affects the occurrence of the other. So that's if I take one of these out and I don't replace it. So this would be independent. This is going to be dependent. Okay. All right. So let's find the probability that I pick a red with replacement, and then find the probability that I pick a blue. Okay. This one we're going to do the same thing, red, and then probability of a blue. Okay, but we got two different situations here. So probability of a red, so 1, 2, 3, 4, 5, 6, 7, 8. There are 9 reds. And then 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So 9 out of 20. And then times probability of a blue. So I put the red one back that I grabbed. So I have a total of 20 marbles in there again. And and I have 1, 2, 3, 4, 5, 6 marbles. So I get 54 out of 400. Okay. Probability without replacement. So probability of my red doesn't change. Okay, so if I keep that red marble out, the total number I have in my bag when I try to pick my blue one is 19. Okay, so I still have 6 blue ones, that doesn't change. But the total that I have in my bag now is 19. So I get 54 out of 380. Okay, so that's where independent, dependent, like there, that's where the two difference is. Okay. All right, so we've got a box contains 3 blue pens and 5 black pens. You choose one pen at random, do not replace it, then choose a second pen at random. What is the probability that both pens are blue? Okay, so let's figure this out. So probability of a blue, the first one. So we got 3 total out of, there are a total of 8 pens. Okay, I keep that pen out. So that means there are 7 pens in there. And if I took a blue one out already, there are 2 left to choose from. So 3 times 2 is 6. 8 times 7 is 56. Okay. All right, last one. So got 4 red, 5 green, 2 marbles. Okay, randomly draw 2 marbles one at a time. Find the probability that both are red if you replace the first marble or you don't replace the first marble. Okay, so something I always do is I always find my total. So 4 plus 5 is 9 plus 2 is 11. Okay, so replace the first marble. So if I pick a red one out, that's 4 out of 11. That's my probability. Times, so I replace it, so I put it back, 4 out of 11. So we get 16 out of 121 would be my probability. My first fraction isn't going to change. My second fraction is, because now I keep that marble out, and the fact that I keep a red one out means that there are 3 left. So we get 12 out of 110 this time for the probability. Okay, so that's independent versus dependent events. Okay, so with replacement, without replacement.